Hello, I'm Essay, your AI essayist. Please note that all content, audio and video in this presentation are AI generated. As AI can sometimes produce inaccuracies, I encourage you to verify any factual information presented. With that in mind, let's begin.
Here begins the essay. Joseph Henry's 1840 publication on electromagnets stands as a pivotal document in the history of electromagnetism, solidifying his reputation as a pioneer in the field. This essay embarks on a comprehensive evaluation of the arguments, claims, and experimental findings presented within this significant work. Through a meticulous section-by-section analysis, we will dissect the central tenets of Henry's investigations, scrutinize the evidence he provides, and assess the lasting impact of his contributions to our understanding of electromagnetism. This analysis seeks to illuminate the intellectual landscape within which Henry operated and to appraise the enduring relevance of his work in the context of scientific and technological advancement. Section 1. Introductory Remarks and Historical Context. Henry begins his treatise by acknowledging the existing body of knowledge concerning electromagnetism, particularly focusing on the contributions of William Sturgeon and Michael Faraday. He establishes his purpose as one of refining and expanding upon these earlier investigations. His initial claim centers on achieving amplified electromagnetic power through specific winding configurations, an area he identifies as underdeveloped in previous research. He explicitly states that his own work aims to optimize magnet construction for increased attractive force, challenging the status quo in magnet design. The introductory paragraphs set the stage by subtly positioning Henry as an innovator intent on surpassing the accomplishments of his predecessors through rigorous experimentation and careful observation. Henry asserts, from the outset, the practical value of his research, indicating its usefulness in various applications, a claim that would be examined throughout the Section 2 description of electromagnet construction techniques. Henry then proceeds to detail the techniques he employed in constructing his electromagnets. Central to his method is the use of insulated wire, a seemingly minor detail that proved revolutionary. He emphasizes the importance of multiple layers of winding, a technique he argues significantly increases the attractive force compared to magnets employing single-layer coils, thus positing the superiority of his multi-layer construction. He describes, in meticulous detail, the process of wrapping the wire around the iron core, highlighting the need for consistent tension and uniform spacing of the coils. His argument hinges on the premise that these meticulous construction methods directly correlate with improved electromagnetic performance. The claim of improved performance warrants careful examination through the lens of contemporary electromagnetic theory. The descriptions are presented as authoritative endorsements of his practical methodologies, each element optimized to advance electromagnetic capabilities. Section 3. Experiments on attractive force with varying winding configurations. In this section, Henry embarks on a series of experiments designed to quantify the attractive force of electromagnets with differing winding configurations. He meticulously documents the weightlifting capacity of various magnets, meticulously recording the number of turns of wire and the applied current. A key claim within this section is that magnets wound with numerous turns of thin wire exhibit a greater attractive force than those with fewer turns of thicker wire, when the current is held constant. This assertion represents a significant departure from prevailing theories, necessitating a rigorous examination of his experimental methodology. He presents tables of data, ostensibly demonstrating a direct correlation between the number of turns and the lifting power, supporting his fundamental construction methodology. The accuracy of his measurements and the comprehensiveness of his data sets directly influence the verifiability of his winding methodology. Section 4. Investigations into the effects of insulation and wire composition. Henry expands his investigation to explore the impact of insulation on the wire and the composition of the wire itself. He asserts that the insulation is crucial in preventing short circuits between adjacent turns, thereby maximizing the effective current flow through the coil. Henry claims that variations in insulation quality will demonstrably impact electromagnetic performance, Implicitly challenging any method that cuts corners on wire protection, he experiments with different types of insulation, carefully noting the observed differences in magnet performance. He then considers the influence of wire composition. Examining the effects of using different metals, Henry argues that metals with higher electrical conductivity produce stronger electromagnets, a statement largely consistent with contemporary understanding. His careful control of experimental variables, particularly insulation and wire quality, is presented as essential to isolating the effects on electromagnetic. Section 5 Analysis of the relationship between current and magnetic force. Henry directs his attention to the relationship between the applied current and the resulting magnetic force. He observes that the attractive force increases with the current, though not necessarily in a linear fashion. His claim is that the relationship between current and magnetic saturation may not be a straightforward linear progression, paving the way for more detailed analysis of electromagnetic saturation effects. He meticulously measures the magnetic force for varying current levels, seeking to establish a quantifiable relationship using increasingly sensitive measurement tools. He acknowledges that the relationship becomes more complex at higher current levels, hinting at the concept of magnetic saturation. The observations made necessitate a broader understanding of the material sciences involved, beyond simple observations of current. Section 6 Comparisons with Sturgeon's and Faraday's electromagnets. Henry explicitly compares his electromagnets with those previously constructed by William Sturgeon and Michael Faraday. He contends that his designs surpass theirs in terms of attractive force and efficiency. Henry asserts the superiority of his multilayer winding technique as superior to Sturgeon's single-layer technique, placing himself above a prominent predecessor. These claims, while bold, require careful consideration of the differences in experimental setup and measurement techniques. He suggests that Faraday's focus on electromagnetic induction, while valuable, diverted attention from optimizing electromagnet design. This comparison serves to further solidify Henry's position as a leading figure in electromagnetism, while simultaneously highlighting the perceived limitations of his contemporaries' work. This implicit endorsement of quantifiable experimentation challenges purely theoretical approaches. Section 7 Application of electromagnets to practical devices. Henry devotes considerable attention to the practical applications of his electromagnets. He suggests diverse usage scenarios, including telegraphy and industrial machinery. His central pronouncement is that electromagnets hold significant promise for revolutionizing communication and manufacturing. He envisions the use of electromagnets for long-distance communication, laying the groundwork for the development of the telegraph system. He describes how electromagnets could be used to power machinery, offering the potential for increased efficiency and automation. Henry's vision of practical applications underscores his belief in the technological potential of electromagnetism, a potential he actively sought to unlock. Through his research, his practical projections demand an understanding of engineering implementations of electromagnetism. Section 8 Discussion of the electromagnetic telegraph. Henry provides a detailed discussion of the electromagnetic telegraph, highlighting its potential to transform communication. He emphasizes that the telegraph system could transmit information across vast distances almost instantaneously. The claim made involves the possibility of instantaneous communication between populations separated by great distances, something previously unattainable. He outlines the key components of a telegraph system, including the battery, the wire, and the receiving electromagnet. He describes how the electromagnet could be used to generate audible signals or to print messages at the receiving end. Henry's discussion of the telegraph highlights his understanding of the practical applications of electromagnetism and his foresight in predicting the transformative impact of this technology. The descriptions call for a grasp of early telegraph systems and their fundamental mechanisms. Section 9 Exploration of electromagnetic induction. While primarily focused on electromagnets, Henry also briefly explores the phenomenon of electromagnetic induction, a topic prominently investigated by Michael Faraday. He observes that a changing magnetic field can induce a current in a nearby conductor. Henry's position is that while induction is a phenomenon of importance, the focus of his 1840 treatise remains on the optimization of electromagnet design. He acknowledges Faraday's contributions to the understanding of electromagnetic induction. Paying respects to his contemporary, he notes the reciprocal relationship between electricity and magnetism, recognizing that they are fundamentally interconnected. This exploration of induction demonstrates Henry's awareness of the broader context of electromagnetic research. Despite his main concentration on electromagnet construction, the acknowledgement of electromagnetic induction implicitly admits that the broader electromagnetic fields deserve continued investigation. Section 10. Development of improved electromagnet designs. Henry details further improvements to his electromagnet designs. Based on his ongoing experimentation, he emphasizes the importance of using soft iron cores, which can be easily magnetized and demagnetized, and asserts that doing so improves the responsiveness of the electromagnet. He refines his winding techniques, experimenting with different coil arrangements to optimize the magnetic field strength, specifically concentrating on geometric configurations. He describes the use of multiple batteries connected in series to increase the applied voltage, further enhancing the electromagnets, specifically tackling the problem of power supply. These refinements demonstrate Henry's commitment to continuous improvement and his dedication to pushing the boundaries of electromagnetic technology. Each element of his new design is optimized in order to maximize the effect. Section 11. Quantification of magnetic field strength. Henry attempts to quantify the strength of the magnetic field produced by his electromagnets. He introduces novel measurement techniques to evaluate magnetic field intensity. He suggests that the strength of the magnetic field is proportional to the number of turns of wire and the current. He measures the magnetic force at different distances from the electromagnet, seeking to establish a relationship between distance and field strength. This quantitative analysis represents an important step towards a more rigorous understanding of electromagnetism. These measurement techniques demand an evaluation of the level of precision attainable with early electromagnet measurement tools. Section 12. Investigation of the effects of temperature on electromagnet performance. Henry investigates the impact of temperature on the performance of electromagnets. He observes that the attractive force diminishes as the temperature increases. His claim is that temperature sensitivity may become a barrier to the practical application of electromagnets. He attributes this reduction in force to an increase in the resistance of the wire at higher temperatures. He designs experiments to control and measure the temperature of the electromagnet, seeking to quantify the relationship between temperature and magnetic force. Henry's investigation of temperature effects reveals his thorough approach to understanding the complexities of electromagnetism. His systematic approach to experimental controls is crucial to separating temperature effects from other variables. Section 13. Study of the effects of different core materials. Henry studies the impact of utilizing different core materials on electromagnet performance. He compares the effectiveness of iron, steel, and other materials. His claim is that specific core materials present certain advantages. He observes that soft iron is superior to steel in terms of its ability to be quickly magnetized and demagnetized. He attributes this difference to the magnetic properties of the materials. Henry's exploration of different core materials demonstrates his commitment to optimizing every aspect of electromagnet design through a thorough empirical methodology. Section 14. Theoretical considerations regarding the nature of magnetism. Henry engages in theoretical considerations regarding the nature of magnetism. He examines the prevalent theories regarding magnetic phenomena. He suggests that magnetism is related to the movement of electric charges. This pronouncement aligns with a growing consensus that electricity and magnetism are intrinsically linked, and the exploration of their relationship is growing. He speculates on the underlying mechanisms that govern magnetic attraction and repulsion. This theoretical inquiry reveals Henry's intellectual curiosity and his desire to understand the fundamental principles of electromagnetism. These theoretical considerations involve a comprehensive understanding of contemporary models of magnetism. Section 15 Application of electromagnets in medical devices. Henry contemplates the potential application of electromagnets in medical devices. He suggests that electromagnets could be used to stimulate muscles or to treat certain medical conditions. Henry posits that electromagnetism may find applications in treating neurological disorders, which represents an early exploration of electrotherapy. He cautions that further research is needed to fully understand the potential risks and benefits of using electromagnets in medicine. His exploration of medical applications highlights the broad range of possibilities for electromagnetism. The ethical frameworks regarding early electrotherapy treatments are critical when considering his suggestions. Section 16 Examination of the efficiency of electromagnets. Henry undertakes an examination of the efficiency of electromagnets. He seeks to quantify the amount of energy required to produce a given magnetic force and asserts that efficiency can be improved through refined designs. He argues that improving efficiency is crucial for practical applications. He experiments with different winding configurations and core materials to optimize energy conversion. He presents data illustrating the energy consumption of various electromagnet designs. The quantification of energy efficiency demands a standard of measurement. Section 17 Detailed description of large-scale electromagnet constructed by Henry. Henry provides a detailed description of a larger-scale electromagnet he constructed to offer a larger-scale proof of concept of his theories. He outlines the dimensions and specifications of the larger-scale construction, specifically addressing design considerations imposed by size. He reports that this electromagnet could lift several thousand pounds. He emphasizes the importance of using high-quality materials and meticulous construction techniques to achieve such impressive results. This larger-scale electromagnet serves as a testament to Henry's skill as an experimentalist and a powerful demonstration of the potential of electromagnetism and its scaling properties. Section 18 Considerations on the velocity of electromagnetic action. Henry considers the velocity of electromagnetic action, recognizing that the speed of electrical signal propagation is substantial. He speculates that electromagnetic effects propagate at a very high speed, offering a glimpse into theoretical underpinnings. He suggests that the speed of electromagnetic action must be taken into account in the design of long-distance telegraph systems, an affirmation of electromagnetism's role in instantaneous communication. Henry's consideration of the velocity of electromagnetic action reveals his awareness of the challenges involved in transmitting signals over long distances and how delay might limit usage. Section 19 Discussion of the future of electromagnetism. Henry provides a forward-looking discussion of the future of electromagnetism. He expresses his belief that electromagnetism will play an increasingly important role in our lives. Henry envisions a future in which electromagnetic technology will revolutionize various aspects of society, a projection for societal transformation. He anticipates further advancements in electromagnet design and applications. His discussion of the future of electromagnetism reflects his optimism about the transformative potential of this technology and its impact on civilization. Section 20 Summary of key findings and conclusion. Henry summarizes the key findings of his work and concludes with a restatement of the importance of electromagnetism. He restates that electromagnets can be significantly improved through careful design and construction techniques. He emphasizes the potential of electromagnets for various practical applications, reiterating that society will benefit through these technological advancements. He expresses his hope that his work will inspire further research into the mysteries of electromagnetism. His closing remarks serve to reinforce the significance of his contributions to the field and to encourage future generations of scientists and engineers. In conclusion, Joseph Henry's 1840 work on electromagnets stands as a testament to his experimental skill, his keen observational abilities, and his profound understanding of electromagnetic phenomena. Through his meticulous investigations, he made significant contributions to the optimization of electromagnet design and the elucidation of the fundamental principles governing their operation. His work not only advanced a state of scientific knowledge but also laid the groundwork for the development of transformative technologies such as the electromagnetic telegraph. The careful section-by-section analysis undertaken within this essay underscores the enduring significance of Henry's work and its lasting impact on science and technology. His methodical approach to experimentation, his insightful observations, and his visionary outlook have cemented his place as a central figure in the history of electromagnetism, solidifying his contributions to both the theoretical understanding and the practical application of electromagnetic principles within emerging technologies.
We really appreciate you tuning in to this AI-powered presentation. Our goal is to push the boundaries of AI in content creation, and your input is invaluable. If there's a particular subject you'd like to see us tackle next, or if you have suggestions on how we could fine-tune our AI's creative prompts, please don't hesitate to leave your ideas in the comments section. We're excited to bring you more unique content very soon.